Hello, welcome back to BlenderSushi Live Noding. In this video, we're gonna take a look at this Blender like a formula example. I was actually stumbled into this blend file the other day, and then I was kind of fascinated by the example provided, especially from these thumbnails. Hey, that looks like a math formula, and it produced this kind of interesting geometry. And this guy is kind of giving it for free to have a look. He actually used Python to do it. I found this video before I stumbled into this blend swap, and then in this video he gives some example of kind of structure that you can create using all the Python codes that he provided. It's kind of interesting, and then it gives me a lot of kind of thoughts, maybe some kind of ideas. I really want to find out about this, and this was apparently done by a guy called Paul. I think Paul Kotelevich. I don't know. Yeah, I think that's his name. Maybe, thanks, Paul, for this blend files. He said he was just find out about Blender Python, and then he codes the Python. This is the first one he did. I think he must be really good with math and formula and those kind of stuff. So I'm gonna take a look at that, and then maybe at some point I will take a look at Sverchok on how we maybe to study this. So if you download that file from BlendSwap and take a look inside, you will be presented with something like this. So this is obviously the layout that Paul used when he was playing around with Python, and then he gave us this almost like 300 lines of Python, and then it has seems to have a lot of math formula. I remember around 5 or more years ago, and I was first starting to learn a bit of scripting, a little bit of Python, and have to understand about programming concept. And then I stumble. Oftentimes I stumble into this kind of math formula, and then kind of interesting, cool result that you can achieve using math, and it's kind of overwhelming for me. So in this video, I want to share my thought about programming, about Python and math formula, and I think this kind of stuff is really the most basic, but probably you might need to use it at some point, and then if it's already presented to you as a node in Sverchok or animation nodes, and you can just use it, it's fine, it's cool, but it's also kind of interesting to kind of look into the code, sometimes, and start to understand the code somewhat. So okay, I look at this file. I open this blend file. Okay, I imagine if I'm like a totally beginner, I don't know about Python codes, I don't know about Blender. Maybe I know a little bit, and then I don't know about programming. I'm scared of programming, I'm scared of math. I imagine this is gonna shock most people, but I'm gonna take you through and maybe kind of give you my opinions about it. So you open this blend file. Of course, the layout is all different. You have the file open down there, and we have this Python kind of if we run a code and then it's given error message, the code will be displayed here. This is the what would they call it, text editor or the script editor in Blender, and you can run the script. This is the script that's given by Paul. It has a lot of parts being commented, meaning it has this hash on the lines, and then that means that codes it won't run. It will only run the codes without the hash. And yeah, this is Python with a little bit of Blender Python just to generate this shape. Okay, so I will save this into new file just for a demo. So from Paul Blendswap description and from his YouTube video demo, he also in here is also say press run script to run the script, and then press tab in 3D view for update, then change presets and press again. Basically, you play around with this code, with the Python code. Okay, as the part that's green and comment it out, it won't be run once again. So if I just try to run it, run the script by clicking this button or Alt P, it says there's a shortcut Alt P. I will press Alt P. You see that the structure changes. So my guess is that, okay, this script can edit selected objects and then turn it into a different kind of shapes. I tested with while selecting a mesh object like this. I'm selecting this cube and then run the script, and it seems to change the form, which is quite interesting. I wonder what's happening. So I make like I duplicate the inside of this object, so I have this object selected and then run the script again. Okay, it seems to be changing the objects, kind of trying to recreate this shape. Now I don't know like the full story of this script, but what I understand is it has this math formula that kind of deform the shapes and kind of generate this kind of interesting pattern. So if I play around with this, maybe the speed, I'll make it like half the speed, and then Alt P again while selecting that curve, that mesh. Alt P, okay, didn't change much. So I start to dig in down there. Here, this is probably the part that's maybe confused most people, is if they try to run this, and then the most important bit is actually this x equal. This gonna kind of modify the XYZ or the vector, the vertices position for the currently selected mesh. It's gonna change it based on this formula. So if I try to comment it out and then run it, it says, okay, fail. Python script fail. Look in the console now. Look in the console. You switch to the console window, which is this guy right here. It says name x is not defined. Okay, the x must be from the formula that I just commented out, right? If I uncomment this, if I do it like this and I comment it like that and then Alt P, still fail because of this guy. Actually, we should uncomment and then leave the tab in, because this is actually part of the loop from up there. Just like in animation nodes, you have like for loop, and this is kind of doing that, but it's kind of really long line and it's hard to see what's going on. And then if we hit Alt P, now it should be working. So I just gonna comment this with 2 hash and then continue on. Okay, do Alt P again. Okay, that's kind of giving a nice pattern. Alt P and so on. So apparently this x, the formula for the XYZ must be kind of the ones that's giving all this kind of cool structure, right? And that should be a good beginning. There's also other example like this. It's gonna modify the TT variables, PP, X, all kind of this number that's gonna generate something like that, or that's not so beautiful. I'll select all these lines and then uncomment it. Uncomment the line. Now I can run that code. It says VS blah, blah, blah. Okay, I uncomment this by accident. Alt P. Now we have something like that. That's more interesting. If I change the speed, I think change the speed to 10, like something like that. nothing happened. Vertex number 4. Well, didn't change much. Probably there's something that I should comment out or uncomment. So this one not so interesting. Let's try this. Alt P. Okay, this one is quite interesting. I kind of like this pattern. And yeah, this is Blender Python doing all the work. This is all coding, but I personally I like noding. I'm like the noding fanboy, so you can call it that way. With nodes, things can be a little bit clearer. Okay, so I will try to emulate all this as a nodes. I'm gonna save this text as poll math formula.txt. Save it in the desktop. I should have saved it as Python, but that's okay. I'm gonna start a new blend file. Okay, nice clean file. Let's check the formula real quick. I'll just gonna change this to py and then reopen it using something like Sublime Text, just like a text editor. Okay, we're gonna try to reuse this formula using Sverchok. Let's have a look. Delete this, switch to Compositing File, save as Sverchok math curve. So that's gonna be the name. By accident, I actually found out that Sverchok already has something called formula or something, generators. Search formula. They call it formula shape. Okay, this is interesting. This is not. This is pretty similar to Paul one. It's a bit aliens. This one node seems to want to do a lot of things. It has number, scale, all that sort of stuff. I have a feeling that this node is kind of a translation of all these math formula. So there's probably endless variations of formula that we can use to generate kind of interesting math curve. But let's have a look at this first. Before I use the Sverchok script node, I will kind of try to make something with this. Okay, apparently Blender just crashes. That's okay. Let's reopen Blender. Maybe there's bugs in the somewhere, whether it's Blender or Sverchok or it's in the Mac OS beta that I'm using, that's causing it to crash. But normally, if I reopen it fresh and then work using this fresh file, it will not crash. So let's okay, it's still loading, so I can't click. I can mouse left click at the moment. Let it set it up everything. Maybe I have too many software opens. I'll close some of these. Okay, now it's working. File compositing. Switch to Sverchok. New formula shape. File, save as. This is going to be SV math curve. Okay, let's have a look at this node then. So we have I times xx, and if we click on it, we have all this formula. It's similar to Paul's one, and there's like heaps of formulas here to try. Don't know where to start and don't know what its symbol does, but x, y, z. So this, if we just plug this into viewer draw, plug this into the vertices, okay, we have something that's not very interesting at all. It's just a kind of a point goes in the XYZ direction. It's just shooting out that way. Maybe this number will control the vertices, of course. Maybe leave it as at 25. We can scale it. Okay, scale, increase, decrease the distance. That's nice. XYZ. We can apparently plug in any kind of XYZ range. That's also interesting. Maybe we can try that later. Let's try changing this to other number. Maybe sine of y. This doesn't seem to change anything, but how about this sine of I? Okay, that's slightly more interesting. Let me change this to I. Let's change this to sine I or cos I. So now it's doing, maybe it's doing kind of spiral. Okay. So if we change the number, okay. The number, when the number grows, it seems to create this kind of spiral pattern. So there must be relations between this x and y and z, right? It's generating numbers. I switch the x into y, so the I must be the incremental number. So a lot of guessing at the moment, but this is a good start. I guess it's starting to create an interesting pattern and kind of imaging, okay, this is the I incremental value. What if we use I times 2, okay, we have that. Times I times xx, and we have this spiral. Alright, that's also interesting. If I want to generate a curve using the, what should I use? We remember we have the UV connection nodes, and so we can do something like that. We can also use the edges, and let's have a look. Okay, that's starting to look nice. We have spiral just by using just combination of this. This guy, don't worry about that yet. I think n times number times f. What is f? What is f? I don't know. If it's as the, okay, the i's, this x, y, z doesn't give much difference at the moment. So I times xx. What if I change this to different formula? So this is interesting. This is just like Paul formula here, all in Python, and it's also have this kind of vertices, object data. We kind of can do the same using just a node like this. Tangent, okay, didn't do much. Okay, we're just gonna leave the x alone. I think let's play around with this. Okay, tangent give that sine times pi. That's not very nice. Sometimes you get this kind of like writing, it's actually saying stop. It's not gonna work. Or it has like divided by 0. See, it says stop. I guess I'm gonna leave it with I. Change the course. You started to get this kind of interesting result, sometimes surprisingly complex. So that gives a stop. It says, okay, that's not gonna work. Yeah, okay, that's interesting. But what if we want to use our own formula, you know, and we don't want to be limited to all this? How do we do that? Okay, then there's another way we can do that, and that's by using Sverchok script node. Sverchok has a couple of script nodes. Script node, the first one, second one, and third one. Each one of them is slightly different. The one I like to use is the first one for now. It depends on what you want to use. Each one has different kind of way of working. Each script node has it comes with this example, okay, and each example is a Python script, and it's gonna work inside Sverchok. And my guess is that we can use whole script inside this script node. Of course, it should work, right? It should be simple. It should be that simple. We can try look at the spiral Fibonacci or the petal sign. That's a good start. Spiral Fibonacci, maybe that's my favorite example. We select one of these example and then use this click to import. Now if we look at the text editor and then find that imported py, let's turn on the line and the coloring. Now we have this script, and if I click on this, it's gonna create a node for us. And if I plug this into vertices, okay, we have like a Fibonacci structure, shapes. This you can use to create flowers, obviously. That's really nice, right? You want to understand what is this? How is this possible? If we look at the nodes, it says def. Def is defining this define functions, and the functions for Sverchok nodes, especially for script nodes, by default it has this. You need to do this kind of def. Define a function. The function name should be svmain, and svmain has this kind of attributes. N equal 1000, this is the default, and C equals 0.1, this is the default of this value, obviously. And then this attribute is the in sockets, it's the input of this node, and it's gonna give output. The output is gonna be this vector, list of vector basically. The input is this is integer and this is a float. This is a really good kind of example for Sverchok script node. And this is the actual what's in between is the actual Python code that's gonna generate these points. It has a little bit of math here, math formula, and it generates all these. It gives the out sockets, and it's gonna return it. So what we need to care about is the one in between here. It's importing all these math functions and math utils, vector euler, all this. But this is for the Sverchok, specify the input and specify the output. We can actually add our own numbers. I will do that real quick, but for now I will kind of imagine, okay, what if we want to use our own formula? Okay, our own formula. How do we do that? if you know Pythons and you know Blender Pythons a little bit, you should actually can go far with this really easily. But if you're like total beginner, I'm gonna tell it to you. So basically what this function try to do, first of all, it says verts equal empty list. Okay, we're gonna generate like vertices XYZ positions that's gonna generate this kind of flower pattern. And then on the next line, it's a first new equal first append. So this is actually, this line is kind of clever. It's gonna append its generated XYZ using this formula inside the loop. This is a loop for I in range 0 until n, for a total of n number of points, which is this guy. Generate points based on that, and then first new actually add the numbers. If I modify this and turn it into, I will turn it into like a sine kind of wave. I'll try to do that, kind of reducing the formula, just make it totally like basic kind of result. You can see here, first new, actually this one actually generate the XYZ. Okay, it's gonna generate a new XYZ vector position per loop, depending on the number of loops we provide here, number iterations. Okay, so inside here, if we actually say, if I say 0 I 0 and reload and update Sverchok, seems to be frozen. I might have made some mistake over here. Let's have a look. Segmentation fault. Not this guy. Another one. Script node out on exception. Append takes only one argument. 3 given. Aha. So this is where I made a mistake. So apparently this first new should be inside another bracket. I think that's what I forgot. So reload and update. Now it's correct. It gave us this kind of points that's gonna generate lines actually, just like a normal line. You can have scale vector that's not affecting anything at the moment. It's probably should be placed somewhere in here. Maybe 0 times C, I times C, 0 times C. 0 times something is 0, so we don't need that. But reload that, and now we can scale our line. So this is just like creating lines. In fact, if we use the UV connections, place it there, we can have a line. Okay, that's cool. We know that. What if we want to create a spiral? Spiral is when we turn in order to make a spiral that's kind of moving in one direction, we kind of need to make the points goes in the sine wave and also in the cosine wave kind of way, something like that. So that's gonna generate spiral. Okay, and in order to do that, we need to modify this using math. And I have to say here that's the math or the algorithm or the formula, that part can be a tricky one, but if we are doing it step by step like this, kind of like we're changing. Okay, I want to add a sine wave here. Okay, I wanna give a sine here. Just put a sine. We can just put a formula like that because we already imported here from math. Import sine, cosine, all these math functions we can use inside here. If we reload and then refresh, okay, we are getting that. All right, we are getting a points that goes in the sine wave, but it's not moving forward. So in order to make it moving forward, of course, maybe we need to put the I in there in a X. Reload it again and then update. Okay, now starting to get something. Okay, okay, that's getting somewhere. Apparently I think if I'm not wrong, the C should be somewhere in here. So I times equal C, I think, instead of putting the sign here because it's affecting the line in the wrong way. Reload, update. Okay, now we can generate that. Don't you think it's starting to look like what we did if you are actually using nodes? But we are using a script now. So basically, yeah, this is exactly what I'm trying to do I'm trying to show you in this live noding video. I want you to kind of, if you're a total beginner and you still learning about Python, you're still learning about noding, and then you get this math formula, you want to be able to create this amazing looking shapes, right? Like curve using those formula, but it's kind of intimidating if you're using Python script. It can be intimidating. It's like trying to do the same thing but in different way. Using Node, it seems to be less scary. As currently we are using nodes and we are using script as well, and kind of, I don't know if this is any scarier or is this more scary or less scary, but I think this is simpler. We could have done it this way: create a line, use a pivot draw and plug the line there. Okay, we have line, and the line goes in the X directions. Okay, I'm gonna give different color. Okay, that's kind of the same thing. And then what's happening in this script node is actually, it's as if we kind of separate all the vector x, y, z. So the x still kind of doing it, and then we give a sine wave in the y, but we plug in the x into the y and we give a math formula to it. So this kind of the same thing, x, and then plug it to the y. So we are getting a very similar result, and we have control over the stepping as well. So that's exactly the same. So which one you prefer, it's totally up to you, but when we start to involve a lot of math formula and a lot of functions, it gets confusing using nodes. Sometimes it's nicer to just using a script node like this, so we can put like a complex function in here, and we can expect something that's looking complex, more or less something like that. So if I give the x is the I, the iterations, and the sine I is the y, and the cos I is the z, what we're gonna get is hopefully like a spiral if I reload it and then update it. Okay, indeed we are getting a kind of spiral. We can control the spiral, I guess. Maybe the spiral need control with the radius or stuff. Okay, with radius, I'm kind of guessing, how do we do that? Maybe we just multiply the sine and the cos. Maybe r, give a radius here. Reload, and it might crash. No, it doesn't like it because we don't have r, you know. We haven't created that variable. Name r is not defined. We need to define it up here. Just add it. It's going to be a single value. Call it radius. Variable is r, and we add it also on the top here in the parameter, radius equal 1 maybe, and then reload. Now we are kind of okay, it's good, seems to be good. We have control over the radius. We can still control the scale vector, the radius of the spiral. Okay, cool. Can we make this spiral goes in a circular kind of way? Maybe maybe we can. I don't know how to make this rotating. Of course, you need, by this stage you need to start to dig into math. That's why you have Google, and you just Google for a math formula that's kind of creating, if you want to make this circle and then you want to also make it spiral coil like that. How do we do that? My quick answer is I don't know. Okay, I don't even know. But if I try plug in the sine here and then reload it, I know that's gonna generate something for us. Maybe sine times cos here. Reload it. Okay. It's doing something. Maybe not what we want, but that's definitely interesting, and we can just starting to play around with the formula. Okay. Don't know what's going on, but that's nevertheless is interesting. So our formula is here, and we have these iterations. I that goes from 0 is gonna iterate the loop, right? Let's say make this into 10, and then we have the c, which is kind of the scale factor, and we have the radius, which is r. So we have 3 parameters that we can play around with. Maybe reduce this to x, to 100, and then we have this formula. We don't know the formula, but we need to put the formula inside the verts new. Actually, with the Paul formula, we have that kind of similar. Okay, we can try all this. Everything that's inside the x, we can just copy. I'm gonna copy this and then paste it in here. And gonna write down verts new and then reload, and it says tt is not defined. Okay, there's some kind of variable that we don't have yet, like tt, pp. We don't have that, so kind of we need to go back and then, okay, we need all this tt and pp stuff as well. Copy that, paste it in here. Let's uncomment this. So the tt and pp must be like kind of important constant, then yeah, something like that. Reload, and name log is not defined. Okay, we need a log function as well. We need log, we need tangent. Let's reload again. See if still complaining. Math domain error. Math domain error. What is that? Math domain error. Maybe we shouldn't use the tangent? No. Don't know why it does that math domain error thing, but anyway, I don't like that. I just change this pp into I and reload. Append 3 given. Okay, maybe here we need to add another bracket. and reload. Now seems to be working, and let's have a look. Let's have a look. We have something. Let's reduce this. Okay, we have that. Let's investigate that thing. Let's quick focus on the selected object. View, select it, and have a look. Okay, that's what the formula does. Okay, it's giving this kind of pattern, kind of like a cookie, like a pillow. It doesn't matter, but I know we modified the formula slightly. I don't know why it didn't work with the tangent, unfortunately, but I think we can try all this. I think the one at the bottom is actually really interesting. I like this formula. Gonna copy that, gonna paste it in here, and make sure we have the indentations, because with Python, whatever inside a form, what's inside the loop should be indented. Basically, we are inside the function as well, so we indent this twice. So the tt equal I, pp equal blah blah blah, x. The x is what's important. Again, we need to put this inside our vertex new file kind of a function. Comment that, and let's reload, and let's have a look. Okay, we get a coil, and here exactly, this is exactly what we want. The coil doing what we want, and we didn't even need to Google. This give us the coil that goes around. Let's investigate this a little bit. The radius doesn't have effects because we, of course, our radius is not part of the, it's not part of this functions. Maybe we can just add it in there. I don't know, I'm just testing it. Reload. Okay, radius affecting something. No, we're not gonna do that now. Reload. However, we can investigate this. So we have 3 times cos, and then cos, and then 3 times cos. So maybe this number 3 is something that we can modify. Reload. Okay, 3. Okay, that seems to be affecting the radius, so we just gonna put the R in there. Reload. Test it. Okay, indeed that thing is affecting the radius for our this interesting looking coil. Let's reduce the number there. So the coil is apparently not, it's not like a one-time coil. It's doing it a couple of times. But we can adjust the scale, and there you go. That's a single coil. Oh, it's kind of, oh, it goes into this, that thing is doing the second time, it's doing multiple time. But scale affecting the coil, the radius affecting the coil. Okay, maybe if we really want, we just before it's doing the second time, we just enable cyclic. Now it's like a full coil, and we can bake it. Obviously, now we have nice looking coil there, and we can turn this into a curve, convert to curve, and give it a dimensions depth. Cool. This is exactly what I'm trying to show it to you. Basically, I was inspired by this, of course, these Python codes by Paul Kotelevitz. This actually this is like a bunch of variables, okay? It's parameters that you can change, and then there's this this is a little bit of BPY context active object data. Whatever we're selecting, whether it's a curve or a mesh, it's become the object data. And with the object data, do this object mode, set it to objects, okay? And then it's starting to see, okay, for vert in object, for every vertices in objects currently selected object, vertices make these modifications. That's what that thing is doing. All this kind of stuff, it's gonna modify the vertices, and then at the very end, vertex coordinate equal the new vertex coordinate, the modified version, okay? Something like that. It's something that apparently you can do using nodes, which is the script, the formula shape. This gives you a bunch of formula you can test. Okay, it's gonna adjust the iterations, the X. This node, single node, does a lot, and it's worth looking. But I'm also showing it to you that we can use something called script node. Script node is kind of like a semi-procedural, where you can you do a little bit of coding, but the codes, in this case, the codes only kind of spit out a list of vectors, and with that list of vectors, you can turn it into lines using these UV connections. So that's kind of like a lot of information, but of course, the cool thing is, if we are only thinking like in terms, okay, this script node is kind of like there's unlimited possibilities here, right? In this case, the script only does spit out vectors, list of vectors, and we can use the vectors, whatever we use it for. Maybe creating a curve, or maybe if we want, you can create like a box here, and then maybe you use these vertices to kind of clone the box. You can do that quite easily as well. Something like that. You're instancing the box like that. Maybe you want the rotations to be following the lines. Maybe plug that in, and I don't know, maybe something like that. Or maybe there's a script node that's kind of doing the Euler rotation to Euler XYZ, and then load it, and then I don't know, maybe plug this in there. Maybe, yeah, maybe something like that, and then yeah, whatever you're trying to do, basically you have this ability to create your own nodes really quickly. This is kind of like good for prototyping. It's not like a real Sverchok node. Maybe it's not so much difference anyway, but this is really powerful, I think. Similarly in animation nodes, you can do the same thing. I have not touched that part of animation nodes using math formula, but it's a very similar thing. It's kind of once you understand a little bit of Python, and you understand how this how looping works and understand about parameter, and you worry less about the math. The math itself is another different kind of world, different complexity. The formula like this, like the what Paul gave us, is some of the formula that will give like a beautiful kind of math curve. But anyway, what's I'm hoping if you're watching this video, and okay, that's a lot of information, but I'm hoping that you're not afraid of all this complexity, because you can use it. Okay, the formula itself, math formula is one thing. Okay, Python scripting is another thing. Like a programming concept is another thing. And then for person that's using a lot of nodes, in the end we only kind of worry about the input. We only about the input and the parameter. Okay, and we can worry about the output as well. But that's exactly why the nodes is so compelling for me. Nodes can kind of contain all this complexity, and you have kind of a way to control the complexity, turn it into something you can easily modify. Like this, the formula I can just copy paste from this example by Paul, or maybe you find another formula on internet and you're thinking, okay, I want to copy paste the formula. Okay, but the formula contains numbers, and you have to think, okay, these numbers, which number is growing, which number is changing, which number is should be a parameter that we can tweak. That kind of things that's in the end that's kind of matters, I guess. Obviously you can go really complex with the algorithm and the formula here in not just this really simple example like making spiral, or for like not like this is actually the most basic, kind of basic, but you can go far if you understand this really well. Yeah, I remember I used to be kind of afraid of programming. I won't even touch programming. I don't understand why people like typing print and typing letters, and then you use all this kind of conditional and all this. If eventually if you have a bit of curiosity, because you really want to achieve that kind of look, okay, you without math, without the formula, you might not be able to create this unless someone create a node for you. Okay, here, this is a node for you. You can create this kind of objects. Okay, and this node, okay, this node has a bunch of parameters. You just change the parameters. There you go. You can be an artist. You create this. In a way, that's kind of a big lie. It's a nice thing that the person creates that that node or that program for you to be an artist, to generate this kind of stuff. And you might think, okay, hey, I can generate this kind of thing. It's amazing. But if you're really like if you really want to understand more, you become the person that create the nodes. I'm not a developer. I'm not yet like I don't understand how Sverchok or animation nodes work inside Blender, but I kind of like in between. I want to be a little bit of artist, a little bit of being able to code as well. So this is, I guess, this is a good understanding that I want to share with you in this video. You might be using other software package that allowing you to do this in a different way, but anyway, anyway, I don't know. That's all for this live noding. Hopefully you understand a little bit more about Python and what Python can do, and what's add-ons like Sverchok can do as well. You can do similar thing using animation nodes, but I really think Sverchok is better to generate this kind of mesh. Animation nodes can do it as well. Maybe I'll do that in the next live noding video, but for now this is yeah, pretty much what I want to show to you. Thanks again for tuning into this video. This one is kind of complex, but if you understand this, you can go a little bit further, I guess. I'll see you in the next video. Thanks for tuning in. Please like this video and leave comments below if you have something you don't understand, you want to say something, just give a feedbacks. Maybe I should explain it like this, you know, explain it simpler. I cannot explain it any simpler, but this is based on my knowledge at the moment. Yeah, anyway, hopefully this is useful. I'll see you in the next video. Thank you. Bye.